Welcome to direct and inverse variation. Let's get started. Now, when y varies directly as x, that's direct variation, and we write it as y equals kx. And my k is a constant. It's called the constant of variation, as you'll see on your notes sheet. And when y increases, or the value of y increases, then the value of x is going to increase. When y decreases, then x will also decrease. So looking at this example here, if y varies directly as x, this piece right here is telling you that y varies directly as x, so we're going to use this relationship, y equals k to the x, which we have from up here. Then it says y equals negative 15 when x equals 5. That means if we were to plug in negative 15 for y, we have a k, and then they said x is 5. So when y equals negative 15, when x is 5, we can find our constant. And we do that here by dividing both sides by 5. So our constant is negative 3. Then, and you'll see over here it says, then find y when x equals 3. So now we continue to use this equation. So we're going to find y, we don't know what it is, when x is 3. Now we have a k. We found the constant, and the constant will stay the same for this problem. So we plug in for k, this negative 3 that we got, and then it tells you when x equals 3. So our y equals negative 9. So the first part told us our relationship between y and x. The second part is what we use to find our constant. Then we can actually solve for what they want, which is y. Now inverse variation is when we have y equals k divided by x. So instead of k times x, we have k divided by x. K is still my constant of variation. And instead of both of the variables increasing, when y increases in value, my x is actually going to decrease. And when my y decreases, my x will increase. So let's look at this example. Now you have an r and a t. If you're going to get different letters, but if you want to remember them as y and x, you can do that too. If that helps you every time, that's fine. But I do want you to get used to seeing the different letters, so that's why I'm going to use r and t. So this tells you right here, if r varies inversely as t, that means we're going to use our inverse equation here. R varies inversely as t. And again, that's the same as this. Y equals k over x, r equals k over t. And the second part, r is negative 6 when t is 2. So I'm just plugging in. Negative 6 equals constant over 2. And then I can find my constant by multiplying by 2, multiplying by 2. So my constant is a negative 12. And then finally, find r when t equals 4. So now we're still using this relationship. We don't know r. We know our k because we found it. And then when t is 4. So r is negative 3. So again, this tells us what relationship we need to use. This helps us find our k. And then the final piece is where you actually solve and get your answer. Now, if you were to just look at this relationship, a equals 5x, this is a direct variation relationship. You have your same thing as we had on the other slide, y equals kx. Your constant is 5, and you have your y and x relationship there. If you looked over here at s equals 3 divided by t, again, it looks like your inverse relationship. So this would be an inverse variation. And your constant is a 3. But when you look at these relationships, just because this doesn't have a fraction, you might be tempted to say it's direct variation. But remember, direct variation has a relationship like this, where when y increases, x does as well. And inverse is y equals k over x. So when y increases, x decreases. So this isn't set up like a direct variation. If we were to divide each side by x, we would get y equals 10 divided by x. And you can see that's actually an inverse relationship. And your constant is the 10. Same thing over here. Because it has this fraction, you might think it's inverse. But the constant is in a different place. If you were to multiply both sides by m, these cancel, n equals 20m. Well, it actually looks a lot more like a direct variation, where your constant is 20. So be careful when you're doing your practice sheet that you don't automatically just look at it and say, well, there's no fraction, so it's an inverse. That's not the way it works. You've got to look at the relationship between the two variables. That's it for now. Thanks for watching. See you soon.